Hello, ladies and gentlemen. Today we're going to talk about fingerprints. We're going to discuss history of fingerprinting, describe the characteristics, explain when and how fingerprints form, describe how fingerprints can be left on objects, identify basic types, and how criminals might attempt to alter them. We're also going to look into the reliability of fingerprints, the AFIS system, so fingerprint identification system, and explain how fingerprints are collected, describe the latest identification techniques, determine the fingerprint matches a fingerprint on record, and the process. Uh, use the process of lifting a latent print. Well, we might do that when we come back. So let's go ahead and start talking about the history. So we have found fingerprints as old as 3rd century BC in China. So in ancient Babylon, they used fingerprints to sign their names on contracts. So they already noticed they were different. Now, in 1684, if you remember from your history, this is when scientific method comes into play. People are actually, doing science and studying things here. So you get the first paper describing patterns on human hands, including these ridges. In 1788, Johann Mayer, I guess that's how you say the name, noted that the arrangement of skin ridges is never duplicated in two persons. So everybody has their unique set. Now, then we get in the 1800s. Now we've got them describing 9 fingerprint patterns, and Sir William Herschel has a collection of fingerprints, and he's the first one to note that they do not change with age. So, for example, if you took my fingerprints when I was 20 and again when I was 40, they would be very similar, unless I'd scarred them or something. And then we get, oops, my bad, went back. We get ways of identifying criminals. In 1883, we start actually applying these to repeat offenders. Now, in 1888, we look at this, we get a new classification system adopted in the US, and we see like the 10 fingerprint impressions for people. And then now we are looking at the 10 card. Here's an example of the 10 card. So you've got, your 10 fingers on there, as well as sort of a whole hand pressed down here. All right, so what are fingerprints? Your fingers, your toes, your feet, your palms, they're all covered in these little ridges. And we think the reason for this is to help us grip things. So they provide a little friction to help us hold on to stuff. And they accumulate natural secretions and dirt. So you naturally get oils and dirt in your hands. And then you leave these things when you touch objects. You leave a little oil behind. So the structure of the skin, again, I'm not biology, so I won't go too into this, but basically these little ridges go deep into your skin. So if people were trying to alter them, they would have to remove a good portion of your skin, and you'd have just these scarred, mangled fingers, which would also be a way to identify you. So you have the dermis, the epidermis, and then this layer between. And this basal layer grows faster than the layers above or below it. And it kind of collapses and folds to form these little intricate shapes. So fingerprints start forming at about 10 weeks of pregnancy. So in about 10 and a half weeks, you're going to start to have fingerprints, the fetus will. And let's talk about why identical twins don't have the same fingerprints. So what we think is happening is, you have your basic DNA, but then as you're forming in the womb, they think the placement of you in the amniotic sac and the fluids can influence the shape of those fingerprints. So even though two identical twins with the exact same DNA in the exact same womb, they're not in the same space, they're moving differently. are going to wind up with different fingerprints. So we kind of classify them as three general types. So you have the arch type. Now, if you look at the arch type over here, you'll notice the lines come in on one side and go out on the other side. So that's an arch. The whorl, you have sort of this central circular piece and concentric kind of circles going out. So about 5% of the people have arches, about 30% of the population is whorls. Most of us have these loops. So on a loop, you'll see the lines come in from one side, go up, and exit on the same side. So this loop does that on this side, but you can have loops that come in from the others. You're going to notice a delta. So we'll talk about deltas here. This has a delta in it, a little triangular spot there. Most of us are going to have a loop. So we're going to look at your fingerprints too. You can look at yours at home. You may not have a magnifying glass. We will look at them in more detail when you come back. So forensics examiners, they're going to look for these little minutia. So one of the things we can do is count the ridges. So how many ridges are here? What's the ridge area count? There's an example of the delta we just spoke of. So these little minutia are going to be what we look for to distinguish a fingerprint from someone else's. So here we'll see. So this is a central pocket loop whorl. And you can see there's two deltas in here. There's a delta right here and a delta right there. And you have sort of this central whorl going on here. Then this is a double loop whorl. So it kind of looks like you have two loops where it comes in and goes out on this side and kind of coming in, going out over here. And it's sort of making a whorl. You have two deltas in there as well. And then this is called an accidental whorl. So it's kind of a whorl, but not really round like this one. And look at the three deltas going on there. Arches. So this one's a plain arch, just kind of easy in and out. Whereas a tinted arch, you have a much sharper kind of pitched tint-like thing here. And of course, you've got a delta in there too. So again, you can divide these patterns up more as to, what percentage of the population has these things. And again, we note even identical twins have unique fingerprints. So what we're going to look at now is the minutia. So these are the things that are really going to make your fingerprint different from somebody else's. And we say no two fingerprints are alike, but that's just because when we look at the minutia, there's these tiny little details, and there's bound to be one tiny little detail that's different. There have been examples of people being mistaken in fingerprints because what happens at a crime scene is you usually don't get a full print. You only get part of the print, maybe a partial print. So what you're doing is comparing a part of a finger to somebody else's finger. And they may have a lot of pieces in common that are very similar, but you're not seeing that other half, so you don't always know. So we look for the minutia and we try to find at least, 10 to 12 would be a good number of matching minutia to be able to match it to someone else. So, but the minute you see something different, it disqualifies it, right? But so here are some of the things we can look for. So this is a ridge ending. So you can see the ridges are going along and then this one just stops. And here you have a fork or a bifurcation where you have one ridge that splits into two. This would be called an island ridge or a short ridge. And then this one's even smaller, so we may call it a dot or a very short ridge. When you have two ridges running and one cuts across like this, we can call that a bridge. And this is not a bridge because it doesn't connect. So it could be a spur or a hook, we might call it. This could be called an eye, although you'll see a lot of times it's called an enclosure or an island. Oops, too far. Oh, no, I did it again. This one is a double bifurcation. So it starts off and it forks here, and then it forks off again. So you have a delta and a trifurcation. So it's going along and then it splits into three instead of a bifurcation, which was two. So these are the things we're going to look for to determine a fingerprint's, pattern. There's three types of prints. So there's patent fingerprints, and these are on smooth surfaces, but they're transferred like blood or some liquid. You had something on your hands, so that bloody fingerprint that's on the wall, that is a patent fingerprint. We can see it, and we can try to, get it off the wall. Then there's plastic fingerprints. This is when you've touched something, some kind of soft material, and left the ridges behind. So think maybe somebody had broken into your house and you had like some caulk, soft kind of caulk around the window. Maybe they left a fingerprint in that. Latent fingerprints are the ones that you're probably used to seeing in crime shows. They're the ones that we can't see, and we have to develop them. We have to make them visible by dusting or using some chemical to make them show up, and then we can collect them. So there's a lot of different ways that we might do that. So depending on what sort of surface they're on and how you might get them off. So here's one that you might use for paper. And so you're going to spray it and wait 24 hours, and then they should show up as this purple blue print. And sometimes here, plastic, metal, glass, we can do that. We can heat the sample in the vapor tint with this vapor in it, and we might get a white print. Some silver nitrate might help you if it's on wood or styrofoam. So we'll dip it in the silver nitrate and then get this black or reddish brown thing. Iodine fuming. So if it's on paper, cardboard, unpainted surfaces, again, you sort of put the iodine crystals, like maybe you have a tank or a vapor tent, and as they turn to gas, they'll turn the print into this brownish thing, but it does fade quickly. So you're going to have to take a picture of it or do something to record it before it goes away. So can fingerprints be erased? Not really. You can try to peel it off or remove, part of the skin, but it's going to grow back. If you do remove enough to make it go away for good, you've probably, chopped off a part of your finger at that point. Is it reliable? Yes, but you can make mistakes. So I mentioned before about mistakes. There was a bombing, a terrorist bomb on a train in Spain. And they found part of the bomb and there was a fingerprint on it. And they matched it to this poor man in, oh gosh, I want to say it was Washington or Oregon, somewhere up there, state. And they arrested him, and he'd never been to Spain. He'd never been any part of this, but they still were like, you made this bomb, your fingerprint was on it. But again, his were just really similar to this one print. But he eventually got released. So yeah, you can make mistakes, especially if you're not holding that criteria high, so that you have to have so many, minutia marks before you can match it. Can computers perform matches in seconds? That's what we see on TV, but no, it takes some time for them to go through those databases, and it always goes to a person in the end to look at it. So the computer might spit out, oh, these have 14 matches in their minutia, but you're going to send those to a person to then look at. So new scanning technologies. So now, rather than just ink printing people, we can use technology to scan their fingerprints. You may have a phone that scans your fingerprints for your ID. These can get us really minute patterns. Can help, find really little small details in there, and so that's good. Helps us analyze them better. We can also analyze trace elements of objects on the skin. In other words, if you ate a bag of Doritos and then committed some crime, we might even be able to say, hey, whoever did this ate some Doritos before they did it. Technologies that recognize patterns besides fingerprints, there's retina. like an eye scan, your face scans, even the veins in your palm. So there's a lot of new technologies coming out besides just fingerprinting. So, sum it all up, fingerprints have been used for a long time to identify, we think that they're unique to a person. So, if you get enough minutia, this is individual evidence, not just class evidence. If you're just like, oh, it's a whorl or an arch or a loop, and you have a whorl, and this is a whorl, that doesn't mean that's just class evidence, right? It's getting lots and lots of little minutia that match. That's when you can make it individual. So basic analysis, you look at it for all those little ridges and deltas and figure out how many points of comparison you have. So we search for patent prints, plastic, and latent prints. And we dust with powders or we use chemicals to help make those latent fingerprints visible. That's called developing the fingerprint. And then, of course, we try to eliminate any errors by really having a good eye for detail. All right. You're going to have some activities over this. And when we come back to regular classes, then you will do some labs. Have a good day.